Hello again, everyone. We are going to now do the quiz solution video for quiz 10. And I'll write that up here so we know. Quiz 10. Alright, so the first one, identify the expected major products for the following reaction sequence. Whenever you see a boron trihydride, just like that, right? I always call it a boron trihydride, but it's a borane, right? That's actually a hydroboration oxidation reaction. Whenever you have a hydroboration oxidation reaction, what you're going to have is the addition of the alcohol, right? But interestingly enough, usually the addition only happens at the least substituted one, right? But we have both of these are the same substitution right here, right? So an addition at either one is possible, right? So it definitely can't be this one right here because it's not going to add to the end, right? So the only two left are these two, right? So there's an addition here, right, which signifies this one, along with its enantiomer, and then this one is this one over here, along with its enantiomer. So the answer to number 1 would be 1 and 3, right? 1 and 3, E. Next one we have here is a hydrogenation. Right, a catalytic hydrogenation to be exact, because you have palladium here. The palladium / C is catalyst, right? And I don't know when a catalyst ever actually attaches to the thing, so it can't be that one. It can't be that one either because you don't get hydroxyls or alcohols when you do hydrogenation. You don't get an extra carbon when you do hydrogenation, right? And you don't get an extra carbon when you do extra hydrogenation. So all those are wrong. Or you can go straight to the right one, which is this one, where the double bond gets fully saturated or hydrogenated with the hydrogen gas and the palladium. Just remember, I said this a couple times in lecture, a palladium and a platinum can be interchangeable when it comes to it as a catalyst on its own, right? There will be other catalysts that have palladium in it, like Lindlar's catalyst, but that's the poison catalyst. But if you have palladium on its own as a catalyst, it's going to act just like platinum does and do hydrogenation. Next. Okay, so what is the expected major product upon the completion of the following? So this is just a straight up halogenation. Lay? I don't know what that is. Halogenation. Okay. And the product here, since it's 1-pentene, right? So it's literally just, what is it? It's jar pentene, right? So 1, 2, 3, 4, 5, right? And then it starts there, right? And since it's a straight up hydrogenation, right, across the double bond, we get a chlorine here added there and a chlorine added there. So it's going to be, the answer will be 1,2-dichloropentene. Okay. Next one will be, what is the major product of the following? We have a we have a bromine gas and a water. So this is the halohydrin reaction. And so in the halohydrin reaction, we have an addition of both alcohol and bromine, right? And the key here is that the addition of the alcohol will happen at the most substituted carbon, right? And the bromine will be at the least substituted carbon. The only one that has that is number 4, right there. Okay, so that's answer D for number 4. Structure 4 or number 4. Okay, so this is just naming the alkene. This is pretty simple. We have a pentene here, right? And there is 2 methyl groups, one at number 2, one at number 4. There is an ethyl group at number 3, so we can name it 3-ethyl 2,4-dimethyl 2-pentene. Okay, so that's A. All right, next one we have here is pretty simple. This is the syn dihydroxylation. If I can spell it right. Dihydroxylation. There we go. Since it's a syn dihydroxylation, you're adding hydroxyl groups or alcohols in a syn fashion. None of these are syn additions, right? That's an anti-addition. I mean, that's not even any stereochemistry there. There's no stereochemistry there. There's no stereochemistry there. The only one that has a syn addition is the first one. So it's answer I mean 1. A. We have another syn dihydroxylation here, this time with osmium tetroxide. Another syn there we go, dihydroxylation. Again, that's not syn addition, that's not syn addition, that's not syn addition, and that's not syn addition. This one here is the only one that has the 2 hydroxyls on the same side. So the answer here is B. Next, we have an ozonolysis, right? And so it's asking actually what the starting product was for this ozonolysis, which is pretty simple. Remember, you have a carbonyl being formed on either side of a double bond that got broken by ozonolysis, right? So we have 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. So we have a cyclohexene, okay? But then we have to have a double bond, and the double bond is actually right next to this extra methyl group here, right? So the only one that has a double bond next to an extra methyl group is going to be this one, okay? This one's too far away, okay? And this one is also too far away. And that's not the right number of carbons, and that's not the right number of carbons. So B for that one. Next one, identify the best reagents to accomplish a Markovnikov addition of water to an unsymmetrical alkene with minimal skeletal rearrangement. So the key there is minimal skeletal rearrangement. Of all the reagents that you see on these choices, the only one that can stop a rearrangement from happening to form a more stable carbocation is mercury. Right here. It makes that mercurinium ion, remember? So that's going to be A is the answer there. And then the last question, what is the expected major product for the following reaction? The first thing to notice is that we have a tert butoxide here, which is a bulky base. Which means it's only going to want to deprotonate off of the least substituted carbon, leaving you with a double bond at the very end, also known as the Hoffman product, right? So the double bond is going to end up there, okay? And that means the answer is answer 3. Good stuff, good stuff. Or, sorry, C. All right, that is the quiz solutions video for quiz 10. You have any questions, let me know. You can ask them in the comments below if you're watching this on YouTube, or you can send them to me via Teams, or ask me all day tomorrow. At the recording of this video, it's Wednesday, so tomorrow you can ask me questions on Thursday, but you cannot ask me any more questions about things about the test and stuff like that on Friday during the open test hours. Okay? All right, good luck on your exam. See you on either an exam solutions video or the next lecture, which will be about syntheses.